That's about as good as it's going to get.
Hey guys, welcome back to part 2 of our distributor rebuild. So we're at Kurt's shop here, and Kurt's had a look at our distributor. He's going to critique it a little bit for us, and then he's going to set it up on the distributor machine. And then for the rotor, I noticed this one comes with either a rev limiting type rotor versus just a standard non-limiting.
Yes.
What would be the pros and cons of using one versus the other?
Well, the pros and cons are pretty simple. The non-rev limiting rotor is exactly what the name says. It's non-rev limiting. So that means if you want to turn your engine above 6,500, it'll let you do it. And if you've made modifications to cams, heads, springs, all that stuff, then that's fine. The rev limiting rotor on a 911T engine was set at 6,500, and so it was there to prevent further engine damage to mainly valve train is the biggest thing that you're protecting with that rev limiting rotor.
Okay, so with a stock a 911 engine, what would be a safe rev limit to stay within?
Well, that all depends if you're a stock 911T, 911E, or 911S, because there's 3 different rev limits.
Let's just say a T.
T was 6,500.
An S.
An S is 7,300.
Quite a bit of difference.
Yeah, but completely different engines internally as far as cams are considered. So a 911T, you could turn it past 7,000 RPM, but because of the profile of the cams and compression, piston design, you're not going to be making any horsepower at that point.
Yeah. Got it. Okay, well, we're looking forward to you taking us through the process on this. Also, you can bring up some small changes that we're going to make to it while we're here.
Sounds good.
Okay, so Kurt is looking at our distributor in fine detail. And so we just measured out our shim spec here at the drive gear. And we're actually pretty close on target, but he really prefers to use a metal shim on there where it almost has like a thrust against the copper washer. But actually, he's not a big fan of the copper washer. So he's got some here in stock we're going to switch out. So we're going to replace the one on the inside and the outside with a proper set.
Okay, first I'm just going to knock your pins down, all these vents.
And the purpose of those vents?
These are air vents. So where this sits on the distributor, on the engine, it's sitting down pretty low in the engine. And the purpose of this is because you have points opening and closing, so you have sparks. And especially with carbureted cars, you can get gas vapors inside the ignition distributor. So this is an air vent. Allows air to travel in and out of the distributor. Also creates an area where it's not sealed where you could possibly have an explosion from gas fumes. And so that's what these were here, to let air in and out of the distributor.
That's good to know. Okay, so you're feeling pretty confident now. We can go ahead and lock that.
Yeah, it's not a big deal.
Seats it.
Just press it down so it's in the groove, and then I just make sure I grab a hold, lift it up and down.
Okay, so she's locked in there.
Yep, make sure it moves nice and free.
Okay.
So that feels good, and then our basic advance feels good. These are high lead content brass, so the lead gives us a little bit of lubrication.
Okay.
But it's not as soft a material as a copper.
Okay.
And then I'm just going to give that a very light coating of wheel bearing grease. Slide that onto there.
Okay, so what size shim are we using in there?
Okay, I've got a 0.5 on the steel shim, and my brass is a 0.8. But this surface that it rides on here is very smooth. Whereas in here on our distributor, we don't want that brass shim riding up against the cast iron and the bushing. It's going to wear strangely. So we want that steel shim up against it. Then we can just slide that in.
And what size is that shim? Same size as the other?
Correct. So what I'm going to do is use a 4mm pin. And this just allows me to get a setting. So it locks my gear into place. I got my hand on the top so I give it some pressure. And then I'm just going to measure what size clearance we have. Then I can figure out exactly what shim we're going to need to go in there. So we'll take 0.5. 0.40 is on the loose side. So we want this clearance to be right around 0.15 to 0.2 of a millimeter. So I'd say we're somewhere in the middle, probably 0.42. So I'm going to see about a 0.2, 0.25 shim should get us right in the ballpark. Usually I'll set them a little bit tighter when everything's brand new because these brass shims are going to wear a little bit. Okay. So I think 0.25 will give us optimal. That should give us a clearance around.
And then we're going to go with our original drive gear.
Correct.
Okay.
0.15 feels good. I'd say we're right there, maybe just a hair bigger than 0.15.
Okay.
So I would call that good.
Okay, let's do it. Okay, so this is your special pin driving spot. I can see you've done a few pins there.
Yeah, just one or two. Wow. Started off up there at one point.
Now, do we need to pin over both sides or just
no,
one side?
This is, once it's in, this is usually pretty good with these pins. You've got to be careful though, because you only get one shot at it. So if we have to take this pin apart, then we got to throw it in the trash.
You need a new pin?
Yeah, end float still feels good. Sometimes when you drive your pin, depending on what size mandrel you used when you were setting up your shim, you always want to recheck that you've got your end float. I don't know if you can see that, but it feels good. So time to put it in the distributor machine and see where we're at.
Wow, look at this thing. You look like a mad scientist over here with this. Something out of a Frankenstein movie.
Old machine. Okay, so what we're going to do, this is going to give us a couple of bits of information. It's going to give us our dwell, which is our point gap right here.
Okay.
So when you set your points up in here using a feeler gauge, what you're actually setting is the dwell.
Okay.
And that measures how much the points are actually closed between openings. And that's how much charge to coil for your ignition side of things. We're also going to be measuring our advance. We're going to have distributor RPM. There's two scales. 1000 RPM scale, which is what we'll start off with. And that's just switched right here. There's a little switch here on this machine. Okay. And then our 4000 RPM scale, which allows us to run up to 8000 engine RPM. So you got to remember everything on this machine is in distributor RPM, which is half engine speed.
All right.
Okay.
Good point. What is all this stuff over here?
So these are vacuum gauges. So if we had a vacuum advance module, I would be adjusting it here. I've got a hose, and this is a condenser meter. This is for measuring and testing our condensers.
Okay.
So what we're going to do, we're just going to turn it on. It's going to make a little bit of noise.
Okay.
And we're going to get some flashing right here. So first thing I'm going to look at is my dwell and get my points adjusted.
Okay.
Okay, so what we're looking at here is on the scale. It's actually pretty close. We're at 36 degrees of dwell for a 6-cylinder. And we want to be right around 38 degrees. So I'm just going to...
Okay.
Yeah, pretty close. So we're right about 39 degrees. So 38 to 40 is where we want to be. So next thing we're going to do is I'm going to move my scale right here and I'm going to zero it. And if we see each one of these flashing lights is going to be each one of the 6-cylinders that's firing. So I want to check and measure how my points cam is, which is this part right here. These have to be within plus or minus 2 degrees of each other.
Okay.
So if I look at this one that's zeroed right here, this cylinder is about 1 degree off. This one is about a half degree off, about a half degree off, about a half degree off, about a half degree off. So that means what this is doing is measuring the flats on each one of that distributor posts. If we've got more than a 2 degree separation between the highest and the lowest, that'll give us changes in ignition timing to where it'll be like 4 degrees out between cycles.
Okay.
So next thing I want to do is I want to measure the start of my advance. So I'm turning the distributor right now at about cranking speed. When I increase my speed, what I want to see is what RPM my timing starts to move. So I've got first degree and a half of movement is right at around 450 to 500 RPM. So if I back it back down a little bit, you'll see it comes back in. That's 450, so that's going to be 900 RPM on your engine. And then as I increase it up, we get a 2 degree jump. So that means your advance is starting right at around 900 to 1000 RPM. Next thing I want to do is look at my advance points, and generally what I do with that is I'm going to look at them at 250 RPM increments. So I'll go up to 750.
Okay, so you're writing down all the specs.
Correct.
Specs to figure out how to make your adjustments.
Well, we'll see where it lands in the curve to begin with. So just as important as you accelerate, you want your advance curve to move up. Coming back down to an idle is equally important. If the distributor hangs so you can't pull it back, so there's 1,000 RPM, we're back to our 2 degrees. Okay, that would be 900, we're at 450 distributor, we're pretty much back. Okay, it's right there.
Okay, Sensei, what do we got here?
Okay, so what we're doing is we're comparing the readings we took on the distributor machine to our actual readings on our distributor graph. And this was 0231 159 001. That's your distributor right there.
Okay.
Our start speed, which I didn't actually write it down, but we are right at 450. So right here is our start of advance. So you're within the bell curve right there. And each one of these, what we're going to do is we're just going to follow this across. So if we come up, next speed we had was 750, and we had 5 degrees. So that's going to put you right here, right in the center of the bell curve. That looks great. At 1,000 RPM, we had 8 degrees. So that's going to put us right here. At 1250, we were still holding 8. So if I bring it up, we're right on the very bottom of that curve. So if I was to draw on this, we'd be kind of coming, this is pencil, I can draw on it. We would be coming up something like that.
Okay.
Then 1,500 RPM, we climbed up to 9 degrees. So we're right in that. We held that 9 degrees. Let's see, all the way up to 2,022.50. So we bring this line up to here, pick up there. At 2,500, we're climbing again. So we're kind of following the bottom side of that curve. 2,750, we go to 14 degrees. So we're climbing up here. 3,000, sorry, we're at 13 degrees there. 3,000, we climb up to 14 degrees. And then we hold that 15, climbs up to 15.5 right at the last.
So we're kind of in the ballpark.
It's actually pretty good curve the way it's climbing along. So as long as you're somewhere in between these two lines, you're usable. To go in and make a change at this point right here with this particular distributor is pretty tough because of the way that the advanced curve works. In the later model, the 184 series distributors, where they use a stepped secondary spring, so you have two springs that I would call two primary springs. And you're working with deflection and extension on the springs. You have two different size weights. Those are very hard to tune. With what you've got here, I would be more than happy to run with that. You're right in the bell curve all the way up. You're not starting too late or coming back down too late. Everything on the startup. This is kind of the most important part right here. I want to see this fast climb and hold as quickly as possible, which it's doing. This line across here where it's holding, yeah, it could be a touch higher, but I wouldn't go in and make any changes because we just barely hit our 450 start point. So if I wanted to increase the height of this, I would decrease my spring pressure. That's going to bring our starting point back over here somewhere. And what that's going to result in is a tough return to idle. especially because a lot of guys like to set carburetors idling at 1,000 RPM. If you've got a distributor that's starting its advance at 800 RPM, you're going to have deceleration issues where that idle's not going to want to come down and be nice and smooth.
So what should our car be sitting at idle?
On your car for that year, I'd set it right at 950, between 900 and 950.
And our distributor looks good with that RPM.
Yeah, even up to 1,000. You're into it 2 degrees. And this is another reason why we don't set ignition timing at idle. If we set our ignition timing at, say, 0 at 1,000 RPM, and we've already got 2 degrees of distributor, that's 4 degrees. That means our total advance is going to be higher than it should be. So we always want to set ignition timing at 6,000 RPM, which is the end of the curve. On your car, it's going to be probably 30 degrees at 6,000, but let me check that number. And that means your static idle speed is going to be around 0 for ignition timing. Okay.
So I think we're okay then on our setting, and we'll just...
Yeah, but we got to try and address some of that points bounce. So when we saw all these lights lit up, that means that what was happening is this little spring right here doesn't have enough force to control our points. And what was happening is as the points closed, instead of closing and staying against this subject, against this block, they were actually bouncing off the block.
They're floating.
And this is a problem because today the points that we have available are a replica. The original Bosch ones haven't
enough tension on there.
Exactly. So what I'm going to do is I'm going to shim this. I'm going to use a little 4mm washer, and I'm just going to give it a little bit more preload on that spring. It'll help contain it. But this was also one of the issues that these cars fought against. Was points bounce. It was also an issue why they went to CDIs as well, because if these points can't stay closed for any length of time, the coil can't get saturated enough to give enough spark energy. So you saw here when we were about halfway through our RPM range, we started getting a points bounce over on this cylinder. And that was kind of the start of it. And this is one of the issues that they ran into on these early cars that were non-CDI units, and relying on that charge time, was getting enough charge time, especially at the higher RPMs.
So this is the part right here creating all the bounce.
So when we sit this in, we may still have to shim that a little bit, and we'll get it as close as we can, but you'll never get all of that points bounce out. Not unless you go to an electronic trigger. There's 6,000 RPM, and we're just starting to get a little bit there. That's about as good as it's going to get.
Okay, so what are we doing now?
All right, so we got our points as close as we can get. Recheck the dwell. I'm just going to put our little felt dot in.
Okay.
And this little felt dot is there to hold our lubrication.
Okay, so we're lubricating on top of the dot.
Yep, so I'm going to soak that felt dot up with, you can use engine oil. I use ATF oil.
Okay.
And the last thing we have to do before we close everything up is we want to lubricate the point rubbing block. And this grease is...
Okay, special grease here.
Yeah, this is factory Bosch grease. It was discontinued for a while, though now it is back on the market.
Okay.
And you don't need a whole bunch. So what I'm going to do is just roll my screwdriver right there.
All right, and this is more like a wax sticky type grease, so when it gets warm and high RPMs, it won't fling off.
Correct. It is very, very sticky. The problem with using wheel bearing grease or silicone grease or anything like that is as soon as the engine gets up to temperature, you're looking at internal temperatures in the 250 degree range, easily inside the distributor. That grease will melt, it'll fling out, and if it flings out and lands right inside the points, that means you're going to be walking home until you figure out that the grease is completing the circuit.
All right, so special grease is what we need.
Yep.
Okay, guys, so we got our distributor working and set up the way it should be. As you can see, there's a lot to it. Yep. Kurt, thanks for the expert instruction. We appreciate you helping us out.
No problems. Glad to.
Thanks for watching. We'll see you on the next video.